Looks like Zoom is having some issues. That's going to be exciting. Let me see. God, now you're even quieter. Wait a minute. I don't know what's going on.
It's the machine takeover.
Yeah, I know. Today's the day. Might as well be. We're all stuck inside, and machines are like, we can't catch coronavirus. We're going to go roam around the earth, and you people are all stuck. Anyway, so yeah, this one I could do something with. Why? Because this is 4 times x divided by x. Opposite operations, they die. That's a huge deal. Whenever you're dealing with algebra and you want to cancel something, stop yourself and go, are there opposite operations? So often I would have somebody do 3x minus x equals 3. What? The x's don't cancel each other out, right? Because they're not opposite. This is times and this is subtraction. There's no way. But what is 3x minus x? What is 3x's minus x?
2x.
2x's, yeah. Yeah. Okay. Any other questions on homework? So I kind of did this problem for you a bit there. So you're welcome. Is this true? I'm getting a little worried. I expected more questions because some of the homework gets a little bit funky.
No, that was the only one I couldn't remember how to do.
Okay. All right.
Oh, you know what? No, let me take that back. Okay, number 2. Like, what are they asking?
Number 2?
Correct. All of them.
Oh, okay. So they want you to, these kind of problems, I kind of hate them. They're a little bit, pretend like you're going to add 1/3 in 21.
That's it?
And of course, if you have a fraction and a whole number, what should I do with the whole number to make it easier to work with?
Put a 1 underneath it.
Yeah, okay. So if I was going to try to add those, they want you to make like denominators.
Oh, that's that.
Oh, wait a minute. Let me read this again. I am completely lying to you right now. I sort of assumed what they wanted, and that's not what they want. So it says write each fraction with the given denominator. I read that too quickly. I thought it said write each fraction with the same denominator. So they're giving you, they want the fraction to have a 21 on the bottom. Right? They want this, so they should have said like this, 1/3 equals what over 21? That's what they're asking.
Oh, okay. All right.
Yeah.
Gotcha. No.
I thought it was more interesting of a problem, but no. It's just weirdly worded. I agree with you.
Yeah, I didn't understand the directions. Okay, I get it.
Yeah, they should have written it like this. So you can write each one like this. 1/3 equals what over 21? 7/3 equals what over 18? Yeah, just make the denominator that. I like it. So that's the opposite of reducing. That's building it up. All right. How's everybody else? You guys all right out there? No questions at all? That always gets me a little, well, I could be an optimistic fool and just think everything's going fantastic, Jeff.
Jeff,
Yes.
like right there on that, where you was doing when it says just make it instead of them putting the equal sign, they said make the 21. I'm right up here at 2 again, A, in that section. And so they just want us to basically create what it was before it reduced to that.
Yeah, that's a good way to say it. It's sort of like, see, here's reducing, and this is the opposite of reducing. It's building it back up. So somebody
Right.
had something over
7/21.
21. Yeah, so somebody had something over 21, and they reduced it to 1/3, and they're just asking you, like you said, I love it. Can you build it back up to what it was before they reduced
Right,
it?
so that's 7. Yeah.
Sure. Yes. I mean, just don't give too many answers away.
I understand.
All right.
Just making sure. Okay.
But yeah, you're right. You're right. That's all you got to do. I have to multiply this by 7 to get it back up to 211. So I got to do the same thing to the top.
Man,
to
I wish
keep,
they would have just put an equal sign.
well, it
But
would
I
have been,
guess I got to understand what that means and read the top.
yeah, exactly. That's the same thing I had to do. I read it too fast and I had to slow my roll.
Right.
Yeah.
At least you
All
did
right.
better than me. I didn't read it at all. That person.
I
Okay.
understand.
Thanks, Jeff.
Sure. Okay. I'm guessing everybody else is fine. All right. All right. So what's happening tomorrow again?
Quiz.
Quiz. Yes. And let's talk about right now. Let's talk about what's going to be on that quiz. Let me spotlight myself. Um, I think I've decided I'm not going to include section 2.3. So it's going to be 192122. Because I have a feeling, even though nobody is asking me questions, I have this feeling that 2.3 is possibly a little rocky for people, but I don't know. Or you guys just haven't even tried it yet. I don't know. It's one of those two things. Remember, 2.3 is the one that's got all the volumes and all that stuff. So we talked about these problems here, right? And the big thing was that what I told you was that volume of a sphere is going to be really important. Okay. And I will agree to this. They if it's so important, why didn't they do a better job of highlighting it? I agree with you. That's why I did it for you. So right here they say you're going to have to do a web search. Why the shit would you have to do a web search? Why can't you just tell us? Remember this guy? That's the volume of a sphere. A sphere. So if I knew the radius of the Earth, I could figure out the volume of the Earth. Ah, I like it. Roughly, because it's not really a sphere. Okay, so that's going to show up a few times throughout that homework. So just to make sure everybody heard what I said earlier, the quiz tomorrow, and remember, there's no class tomorrow, but I will still have office hours, the extra office hours. And what were they? I think on Thursdays they're 2 to 3, is that right? I think so. You guys with me? So I'm gonna activate the quiz tomorrow morning, and then you'll have until Friday, sometime Friday, to finish it. So if you don't even want to start it and you want to come to my extra office hours and get some help before you start the quiz, hey, that works, right? Or you can start it tomorrow morning, get it done and over with. Either way. All right, let me stop for a minute.
No,
Does
I
anybody-
like the other. I like the Friday.
Yeah, sure. Yeah, whatever works.
Yeah, the
So I
Friday
think
one.
that's, I don't want to give not enough time. So I think if I made it due that same day, there are people that work insane shifts and there would be no time for them to do the quiz. So I try to make it at least due 24 hours later, because there should be time in a full day that there's hour or something you can set aside to do the quiz. Yeah. Okay. Hey, I do what I can. So let me clear this. And I'm going to stop asking you if you have any questions, because you already know you can ask them. So if there are no questions, we're going to go right back into where we left off. And we're going to deal with this stuff here. Yeah, baby. So what I want to do is I want to get off my ass for once and get up on the board. The board. I feel so at home on the board. I hate this. I hate this. This is page, where'd it go? 190. Oh, crap. 192. Yes, 192 in the book. But I'm going to write some of this up on the board so we have it to reference. And we're going to do some example problems. What's up? Okay. So I'm going to stop sharing right now. You can go to 192 in the book if you want to. And I'm going to write what we need up on the board from this whole business here. And when we do the quiz for this section, I will give you all the stuff you need. You don't have to memorize this stuff, even though you really should know. All right. Let me stop sharing. All right. So let me come over here. look at that weird shit that's left over from my other class. Ooh, what is that? All right. So let me start with something that a few of you should be able to do already. If I have 4 feet, and we've done this before, if I have 4 feet, how many inches is that?
48.
Yeah. Right?
Right.
And how did you get that? Because there's how many inches in a foot?
12 inches.
So then I multiply 4 times 12 and I get 48 inches. I love it. So conversion basically boils down to, do I multiply or do I divide? So to show you an example of that, what if I had, what do you got, Jeff? 72 inches. How many feet would that be?
8.
Hold on. Let everybody think about it for a second. All right, now tell me.
6 feet.
Yeah, how'd you get that?
12 times 7.
Jeff, this is awesome.
6. 12 times 6, rather.
There you go. So to do this problem, you have to divide, right? So if I had 24 inches, I would have 2 feet. I got to divide by 12, right? So if I take 72 divided by 6, I get 12. Jeff. Yeah, you get 12. All right. Okay.
Wait a minute.
Why not the
You said-
opposite?
That's 12 feet you got in there.
Oh,
No,
yeah.
6
Yeah,
feet.
Think. I knew I had the wrong number in the wrong place.
exactly.
What I want to do is I want to show you when the units get a little bit weirder. I want to show you a very organized way to do this, because we're not always going to know immediately, do I multiply or do I divide? So let me show you, let me give you a really freaky conversion. Not that freaky. Some of you guys might know this already. 1 inch is 2.54 centimeters. Let me see if that's the same thing. Sometimes they round it weirdly. Did they tell you that? Yes, good, perfect. All right. That's a conversion that maybe a few of us knew already, right? And very often, sometimes when you're working in like a fabric store, you might know this, or construction or something, you might know this conversion. So what if I had 760 centimeters? How many inches is that? So let me show you this. This is kind of cool. Some of us might be able to tell pretty quickly, do I multiply or do I divide?
Right.
Let me show you a really cool way to make it tell me what to do. Just stay with me. So I'm trying to take centimeters to inches. So let me put down here. Here's where I am, 760 centimeters. Now watch, this is kind of cool. I want to multiply by some conversion thing here. So for example, up here, here's what I was thinking about doing earlier. Up here, what I did was, if I have 72 inches, what we really did was we multiplied by 1 foot for every 12 inches. So this means 72 divided by 12. No. So here, what do I not want? What units do I not want?
The centimeters.
Centimeter. I don't want them anymore. So where should I put centimeters? Where should I put centimeters? Top or bottom, so that they cancel? If I put them here, these are just going to make square centimeters. Do I want square centimeters?
No.
No. So where should I put centimeters?
The denominator, the bottom.
I love it. Stay with me now. Just stay with me for a little bit. Just a little bit. Well, actually, for the whole class. But and then on the top, I'm going to put inches. Now, do I have a conversion between the two? I do. 1 inch is 2.54 centimeters. So now, why does this work? Isn't 1 inch equal to 2.54 centimeters? Aren't they equal? Right? Stay with me, stay with me. I love you guys, I love you guys. 1 inch is 2.54 centimeters. It just is. That's the conversion. If you look at your ruler, right, you'll see 12 inches on one side and you'll see 30 point something or other on the other side. That's the conversion between inches and centimeters. Okay. So what is 1 inch divided by 2.54 centimeters? You guys, I could just feel, you're all like, what's this guy talking about? Aren't they the same? Aren't they equal to each other?
Right. 1.
Yeah, it's 1. Yeah. So what am I, do you guys get that? It's sort of like, what is 1 foot divided by 12 inches? It's freaking 1, because they're the same thing. They represent the same thing. So am I allowed to multiply anything by 1? Yeah, you can do that all the time if it makes you feel good. The thing that happens here is, so this is a version of 1. That's why I'm allowed to do this. But it's a version of 1 that looks very freaky. And what does it let me do? Don't the centimeters cancel? And what's left? Inches. So if I do this, and what does this tell me to do? 760, what's the operation I'm going to use?
Division.
Division, yeah. So if you just do 760 divided by 2.54, you'll get the answer. If somebody will do that, that'd be great.
Where's mine?
I think it's like 29. Let me think. There's too many operations there. 29 or 30, somewhere in there.
9.21. I thought it's a long number.
What is it, sorry?
It's 299.212.
299.2.
299? Oh, I see what I did wrong. I had 1 decimal off. 29.21, other stuff? Okay.
Yeah.
Obviously, they're going to tell you in some of these situations how much to round, right?
Mm-hmm.
Round to the 10th, round to the 100th. Okay. This little dude is so useful because I didn't think about it numerically. I just thought, okay, where does centimeters go? Here, so that they'll cancel. And then I want to go to inches. And then I could just fill it in with the conversion that I know. So let me prove that to you up here. So we know this is true, but how would this problem look like this? Here I got 4 feet. Where would feet go so I can kill it? Where would feet go so that it will cancel? On the bottom. Everybody see that? That would cancel them, right? And I want to go from feet to inches, and then I fill in the conversion. I fill in what's true about this. 1 foot is 12 inches. And isn't that what we did? We multiplied. So don't sit there and say, why are you making the problem so hard, Jeff? Because we did this problem and that was done. That was done. I'm just showing you what this problem looks like in this format to show you that this still works. So easy ones like feet and inches, you might not have to write this. You with me? I'm not saying you have to. Freakier ones, you might want to write this just to make sure you're doing the right thing. All right, maybe.
So can you hear me, Jeff? Am I on? Yeah.
Yeah.
So like when you go to that 4 feet, it kind of, I mean, I could see it and I'm looking at it. And so you just write down the main thing of what would you say, feet or inches? What you call those?
Units.
Units, yeah.
Yeah.
So whatever the main common unit represents, like a foot represents 12 inches. So that's what you would put on. Go ahead.
I write where I start with.
Okay.
And then next to it, I'm going to put a ratio that represents a conversion I know. So I know that there, and I want to put, and then I think, okay, so I could do this times 1 foot divided by 12 inches, or I could do this 12 inches divided by 1 foot. because either way, this is still 1.
Right.
I'm allowed to do this, but why would this be silly? What would the units be at the end of this? If I did this, what would the units be?
Feet.
4 feet times 1 feet is what?
5 feet. 4 feet.
Come on, 4 feet times 1 foot is
4.
4.
4 feet squared.
Thank you. All right, and then it would be divided by 12. That doesn't mean shit. Square feet per inch, that doesn't mean shit. So that's not the right way to set this up. Why not? Because I didn't make sure the feet canceled. They actually kind of built themselves. I said, I want the feet to cancel. I want the feet to cancel, so they got to be down there. So here, let me do another problem with this. That's the other way. Right, here we go. So what if I had, using the same conversion, what if I had, what do you got, Jeff? 8.07 inches, and I want to know how many centimeters that is. So if I write down here 8.07 inches, and I want to go from inches to centimeters, where would the inches go and where would the centimeters go?
Inches will go where you can cross cancel, which is the bottom right.
Donnell said it perfect. I love it. So you say, I don't want inches anymore, do I? I want the answer to have only centimeters, so I got to make sure those die. So on the top will go centimeters. And now what numbers do I put next to here? What do I know is true? 1 inch is 2.54 centimeters.
That 1 inch is, right, that's what I was trying to get to, that part.
Now, do you notice how the fraction up here, the conversion fraction, is the opposite of what it was down there? Why? Because here it was centimeters I wanted to kill, and here it's inches I want to kill. But I really want to make sure you understand that makes sense. Just like with the feet and the inches. I multiplied when I was going one way, and I divided when I was going the other way. So this little grid thing helps you remember, okay, here I divide, and I can see I divide because that's on the bottom. So of course I divide. Here I'm going to multiply. Do you guys see that? I'm going to multiply this. So then whatever the hell that is.
20.4978.
Let's round it to the thousandths place. And again, the problem should tell you where to round because you are going to get a lot of decimals in this section.
Rounded to 20.499.
I think it was 49. What was it? 4978?
1,000? Oh, 78. Oh.
I think that's what she said. I'm kind of outsourcing this. I'm not even got my calculator on. So
Oh, you already had rounded it. Okay.
Yeah. All right. Let's do another one. Let's do another
Yeah,
one.
that was a little different. Because of the 1 on the bottom, it made it a whole number. Is that another way you can recognize its multiplication?
Yeah. If the 1 ends up, so that was down there, so I divide. This is up here, so I multiply. And the 1 doesn't do shit.
Right, but that helps me know that it's a multiplication.
Exactly. So you did not have to do this when I said it was 4 feet, right? You knew exactly what to do.
Right.
You knew to multiply. You didn't have to set this up because you kind of work with feet and inches. You kind of know how they operate. But if you needed to, you could set up feet go down there so they cancel. Inches go up here, 12 inches in a foot, multiply. So here's an interesting general statement you can make. And you don't have to memorize this. You never have to use this, but it is useful. Do you notice how when I go from a big unit to a smaller unit, I multiply? Because every one of these has 12 of those in it. So if I have 4 feet and then I cut them up into 12 parts, I'm going to multiply 4 by 12 because each part has 12 in it. Do you guys see that? And so if I go from a smaller unit, what was it? I can't remember what, oh yeah, 72, right? That was the problem we did. And I want to go to feet. When I go from a smaller to a bigger, I got to divide because it takes 12 of these to make one of those. So I want to see how many 12s are there in 72, and that's where we got 6 eventually when Jeff wrote it, right? Do you have to understand or use what I just said ever? No, but it's really kind of useful just to keep yourself on the right track. Smaller unit to bigger unit, divide, bigger unit to smaller unit, multiply. Do you have to memorize that? No, because this process does that for you. It tells you when to multiply, tells you when to divide. Let's do another funky conversion. Let me see what else they tell us. I think they got some, yeah, they got some. Here we go. Here's a good one. Yeah. So 3.79 liters is 1 gallon. Do they tell you? I'm going to push this a little bit. Yeah, there we go. And I'll tell you that 1 gallon is 4 quarts. Okay. So now watch this. So these are, you guys might know this one, especially if you do a lot of cooking or something. 1 gallon is 4 quarts. I always forget those. I have no idea. And this one you might never have known ever. 3.79 liters makes 1 gallon. So what if I knew this? What if I have, what do you got, Jeff? I got 11.2 gallons, and I want to know how many liters that is. Could you set up that grid? Could you do that? Don't say anything out loud. Just take a second and see if you can set this up. Now's the time to make mistakes when I'm not even looking at your work. Even better to not make mistakes, don't get me wrong. So, I mean, let me get you started. You put the 11.2 gallons here.
There.
And then,
Gallons on the bottom.
no, keep it yourself.
Shoot myself.
All right. So now, what am I going to put right there? What units?
Gallons.
Gallon.
I really want that first step to make all the sense in the world, because if you get that first step, and it is that simple, I want him to die, so I need to put that one across so they kill each other, right? If I put it here, they would enforce each other. They would get stronger. Square gallons. What the hell is a square gallon? No idea. And of course, what goes up here? Well, I want to go from gallons to liters, and I know the conversion.
179.
Yeah, and this is, I really want you guys to get this. The first thing I do is barely math. It's writing units in the right place so that these cancel. Now I do the math. Where does 3.79 go? Up here, because it's liters. 3.79 of these, 3.79 of these is one of those. And now I know what to do. Right, what do I do with these?
Multiply them.
Multiply.
Kick ass, right? If anyone's ever taken any chemistry, this should feel very familiar. If you've ever done anything with moles and stuff. And that's not moles that live out in your yard, that's something else.
Okay, didn't know.
Hey, Jeff,
Yes.
for business, is calculus the only math? Well, you said that there's a variety of math that you can use for business, right?
Yes.
But calculus is one?
depending on the level of business you're going to go to. Depends on what degree and how. So if you want to do economic theory, that's going to take calculus. For sure, at least. But if you just want to do accounting or
Accounting.
even business management.
Yeah.
Yeah. Anyway, that's all. I'm sorry, Sal, it's off topic. So what do you guys get when you do this?
I rounded it to 42.45.
All right. Yeah, I didn't tell you. I'm sorry. So yeah, let's do the hundredths place. So is that what everybody else is getting? 40? What is it? 42.45?
No.
Yes.
Ooh, I got some.
48.
Ooh, let's see. So let's see. 11.2 times 3.79. Yeah, 42.45. I said hundredths place, right? So 10s, hundredths. Yeah, I like it. Is that cool? All right, now let me see if I can push this a little bit. Has everybody got this here? It's gonna go away. All right, let me see if I can push this a little bit. Well, what's different about this? What if I have let's say 26.2 quarts, and I want to know how many liters that is? What's kind of off about this question that wasn't a problem before? What's a little bit off about this?
You have
What's a weird
a gap
You have
How do you get a gap?
because you went from quarts to liters, and we're dealing with liters to gallons up here.
Yeah. Do I have any conversion? Do I have a conversion that goes from quarts to liters anywhere? No. I got a middleman here, right?
Right, you got a gap. Yeah.
All right, now stay with me. Does everybody see the problems? Everybody see why this problem is a little more difficult than the other ones? I want to go from a unit to another unit that I don't have a direct conversion for. But what's the path I could take? What could I make quarts into?
turn it to gallons.
Into gallons. And can I make gallons into what I want?
Yeah, into liters. It'll just be a multi-step process.
Exactly. And this is the path I want to take. So the biggest mistake students make on steps, something that has more than one step, is they don't write this for themselves. Watch how this is going to keep me straight here. So I got 26.2 quarts. And I want to, so now I can say, okay, now I want to go to gallons. So where am I going to put quarts? Where am I going to put gallons?
Quarts on the bottom.
Sure. Who goes down here? Sorry.
Quarts on the bottom.
Bam, bam. Now I really want you guys to get this. I can keep going. I'm not where I want to be. I want to be a leader. So now I can keep going. I'm not even going to put the numbers in yet. Screw the numbers for right now. How do I kill gallons? I don't want gallons. So where would I put gallons? And then on the top, I could put liters. That's where I want to be. So each step I've got to take would be another little conversion step. So why did I put quarts there? So they kill each other. And then I put gallons because I have quarts to gallons. Then I want to kill gallons. And then I can go to liters. So what goes here? Where does 4 go? What goes here? So I'm going to use this conversion, right? Quarts and gallons. What goes here?
4.
4, yeah, because there's 4 quarts in every gallon. And then over here, what goes here?
3.7.
Yeah. It's true about liters and gallons. 3.79 liters is 1 gallon. All right, well, I'm going to let you absorb that. What I personally love about this is that the first step, like I said before, is barely mathematical. It's just the units. Make this unit die, go to the next step. Make this unit die, go to the next step. So I always know which way to put my numbers because the units tell me where to put. So since the quarts were here, and it's 4 quarts in a gallon, 4 goes there. And because I had to put gallons down here, 3.79 liters goes up there. So what do I do with 26.2 and 4? What operation is this?
Division.
Division. So I do 26.2 divided by 4. And then what do I do with 3.79?
Multiplication.
Yeah, times 3.79. You gotta love that shit. You don't have to, I guess. But it just helps keep us straight about when am I multiplying, when I'm dividing, by focusing on the units first and then bringing the numbers in. That's almost too nice to believe. So go ahead and let me do that with you so I can be ahead of any dissension. All right. If let's say round that to the thousandths place. Did somebody get the answer yet?
Yeah, it's 24.83. Go 824. Well, you run it often to be 825.
Cool. All right, so let's do this. Let's transition into the book and let's take a look at what they've got now that we've talked about this a little bit. So this kind of grid format for conversions is remarkably useful because it helps us just realize when to divide and when to multiply. Okay. Well, so let's look in the book. Stay there. So we got this stuff.
Yes.
Okay, spokesperson says yes. All right, so let me go in here. All right, so let's fly past this bad boy. So you are going to want to reference this a few times in the next section's homework. And like I said, I'm going to give it to you on a quiz. I will give you the conversions you need. Here we go. So here's where they're talking about that piece. So it could have been either way. It just depends on which thing am I trying to kill, right? So if I already knew pounds, I would use this one because then the pounds would cancel and so forth. But either way, they're both equal to 1. That's what I was trying to say because they're both the same thing.
Mm-hmm.
So here, what does this mean? Write 2 different conversion factors based on the fact that 1 liter is equivalent to 1,000 milliliters. Can you make a ratio? They sort of give it away there. Just to show you, I mean, here's the answer, right? Those are the 2. It could either be 1 liter per 1,000 milliliters or it could be 1,000 milliliters per 1 liter. Do any of you guys have, you don't have to tell me if you don't want to, it's a personal question sort of, but I know Nikisha has kids. I know that much. Anybody else have kids?
Me.
All right. Did you ever have to give medication based on their weight?
Yeah.
Didn't you have to use a conversion factor to figure out how many milligram, per pound or something? If you have pets too, it'll work. If you have pets too, and they have to get medication. I'm sorry, Vu?
I just eyeballed it. Nice plan.
I love it. You're like, let's hope for the best. Anyway, so the correct way to do that is to use some kind of conversion. All right. So if you're going to become a nurse or something, you are going to live by conversions. I mean, it's just going to be conversions everywhere. Let me see. I don't really care about this magic potion they're talking about. Let's see. No. Oh, yeah. All right. So look at number 8. I love number 8. Number 8 is just so beautifully gross. Huh?
Oh, I'm just saying it's ridiculous.
I know. Too bad. So my house is 15 miles from the Gulf of Mexico on the Florida coast, right? So I got 15 miles. And I want to go from miles to what? I want to go from miles to frickin' inches. Why? Because, too bad. So let me I haven't written much there, so I'm going to clear that so I can
Why,
go back.
Jeff? Why wouldn't you use feet? Like inches is not something that's ideal.
So the reason I wouldn't use feet is because number 8 says go to inches. That's the only reason. You
All right.
understand? Yeah. So for some reason, they want to go to inches. Does that make practical sense? No. Does that matter? No, because this is all just about getting practice, right? So very often practice questions in math are really dumb. I will fess up and say that is so true. But, oh, well.
There's practice in everything. I mean,
Yeah, you're right.
everything's practice.
So look here. What do I need to know from this chart to go from miles to inches? There isn't that much. Can you guys see the right thing I need to use?
The feet to the mile equation.
Yeah. So
And
I
then
can
feet to inches.
And then, of course, the other one, yeah, the other one we already know. So all we needed was this one, which I kind of hope some of you guys knew how many feet were in a mile, but that's not necessarily something we use a lot, right? So let me write those down here for us. I'm going to go back to the problem and write them down for us. Yeah, one of them we already know. Where'd you go, problem? Okay. And then I want you guys to set this problem up. So I got 1 mile is 5,280 feet. And of course, I already know that 1 foot is 12 inches. So go ahead and try to do that problem for this very strange person.
You want the answer now?
No, not yet. Sorry. Thanks, Vu. I want everybody to get a chance to write this out. This is the time to do it, because if you make a mistake, I'll never know, and you could just hopefully see what the mistake was. Actually, let me see. I'm going to get used to this dude. Ready? Watch out now. Watch this beautiful shit. Look at this. Talk about something I
Holy
need.
shit.
Dude, I know.
Excuse me. I thought I was at.
What?
No, nothing, sir.
Oh, you're fine. You're fine. I mean, holy shit. I cuss. I think
Go straight.
Oh, because I'm amazing. No, because there's a little piece in here that I can make straight lines without even trying. Woohoo!
That was witchcraft.
It's a little bit of witchcraft too. I'm not gonna lie. All right. So on this first step, so what are my steps? I want to go from miles to what? We basically already said it, but miles to what? Sorry? Feet. And then feet, I can go to inches. I love it. So if you don't have to do the step, but very often people make mistakes because they don't do the step. So this next step, I want miles and feet involved. Where's miles going to go?
The bottom.
The bottom, so that they'll kill each other. And then fit, go up there. Now the next step, where's feet and inches? Where's feet going to go?
Bottom.
Bottom, so they kill each other. And I want to go to inches. And now I can come back in and fill in the numbers. 1 mile is 5,280 feet. And 1 foot is 12 inches. So you just put the number that goes with the unit that you've written down already. So it kind of makes it a 2-step process. And now I just have to just multiply all this stuff straight on through. Let's see. 180. Oh, crap. Let's see. 200 times 5,000. 10,000 100. What's 10,000 100? It's on the order of a million? I don't know. Let's find out. That's right. I got a calculator. Duh. What are you guys getting? Yeah, almost a million. Anybody got that answer yet?
Yeah.
9504.
0, 0.
There's 200.
And that'll be inches. So be really, really careful about, I'm not coming down on you guys. You guys just gave me the answer, but in general, don't forget the units. That's the huge important thing. Did anybody not get that answer? Because if you didn't, it's fine. I just want to show you. So is it obvious to everybody that this means multiply all these together? Nothing's on the bottom, so I'm not dividing anything, right? Okay, so I just throw all this in the calculator and see what I get. I lock it. What would this be in scientific notation?
Nine, 5, 0, 4, 10 to the 1, 2, 3 to the 5th or something? I don't know.
Sweet. Yeah, you got it.
Does the bottom left one stay empty?
Bottom left one. Oh, over here.
Yes.
This one?
Yes.
All right, so I love that question because maybe right now I'll do this. There will be situations where that won't be empty. But of course we start baby steps, right? So that will not always be empty. Let's do that problem right now. In fact, let me look up the conversion. So I'm going to look up the conversion between euros and dollars. So right now, 1 euro equals $1.17, right? And then I'll tell you, get out of here. Do I want to use euros? Yeah, why not? You guys know what euros are, right?
Yes.
Yes, okay.
Those really good like wrap sandwiches things.
Oh. How many euros for the euro? The what? The what? You're thinking about a hero, but that's all right. I know what you're talking about. Let me see.
Euros?
Sorry. All right, let's see. So, and then I also know 1 kilogram is 2.2 pounds, roughly. Okay. So let me use those together somehow. Is everybody with me? So these are two true statements. 1 euro right now is $1.17, and 1 kilogram is 2.2 pounds. In fact, if anybody ever goes to the gym, anybody ever go to the gym like before, you know, our current situation? Yes. If you see one of those things, the weights, it'll have on there something like maybe 10 kilograms, 22 pounds, something like that. It'll show you both, which makes sense because we're the only country that doesn't use that. So, you know, anyway. So what if I had this? What if I had something that cost, let's say, 12 euros per kilogram? You with me? 12 euros per kilo. And I want to change that to so many dollars per pound because we live in America and we need help, right? We don't know what the shit this means. Is everybody with me? I mean, this is something that could obviously happen if you ever get out of the country, or if you have been out of the country and you have different units, you have to know how to convert to get an idea. All right, maybe. clear this out of here. Let me get some room. So here's the thing. Here's how it's going to work. And so I'm going to write 12 euros per kilogram. Now, I don't want euros or kilograms, but let's focus. Which one do you want to kill first? Which one do you want to see die first? We got to kill both of these because I don't want either one. I want dollars and pounds. I don't want euros and kilograms. So who do you want to kill first? Do you want to kill euros or do you want to kill kilograms? Euros? Okay.
Euros.
So where would I put right here? I've got the conversion for euros and dollars. Where would euros go?
On the bottom right there.
Yeah, so that they'll kill each other. And up here, I can put dollars. And let me go ahead and put, what is it? $1.17 for every euro, right?
Right.
So the top is dollars now, but the bottom is still kilograms. So now I want to kill kilograms and go to pounds. Where would I put kilograms?
You want to
Bottom.
Say again?
The top.
It's got to be the top so they'll actually cancel. Do you see that? So don't always put the thing you're trying to kill on the bottom. I do that because it's currently on the top. What if it's on the bottom? Then it's got to go on the top so it'll kill. The idea is put the unit across that you want to die so that they actually kill each other. And now I can go to pounds. And now I fill in the number. 1 kilogram, 2.2 pounds. Am I like, am I up here to you? Is that where I am?
Yeah.
What?
Am I writing
you're-
underneath my picture? Is this underneath my picture?
Yes.
Yeah.
You're getting there.
Oh shit, all right. I'm gonna clear out number 8, okay? So I got some more room. Die, go away. All right, so let me come down here. I gotta remember that. I don't know why it suddenly came to my brain that my picture is in there somewhere. I do think I'm up here. Oh, so let me write down what we got so far. 12 euros per kilogram. So the first thing we killed was euros. So now I'm in dollars at least, but then I need to kill kilograms. And now my kilograms are dead. And now do you guys see what units are left alive? What units are left alive?
Dollars per pound.
Dollars per pound, which is exactly what I wanted. I wanted to know how many dollars per pound is it? Because I'm a crazy American. And now you know what to do with the numbers. Now is where you worry about operations. What do I do? 12
times 17.
Yep, 12 times 117.
Divided by 2.2.
Divided by 2.2, exactly. That's exactly how you put it in the old calculator. In the old calculator. Oh, I better do it. Let's see. It's going to be like 6. Let's see, 12 divided by 2.2. Yeah, what do you guys get? Anybody?
$14.
6.38.
6.3.
Yeah,
6.3.
I get 6.38. Yeah.
9.
No, 6.38.
38, yeah. Just one behind that.
That's right. So it's just 12 times $1.17 divided by 2.2. So it's exactly how you put it in the old calculator. Has everybody got that? Is everybody all right?
Simple for now, but I would definitely have to reflect back.
Yeah, yeah.
I can see it. I would definitely have to reflect back to get
Yeah,
it
yeah.
conditioned in my mind. Definitely.
Yes. And this happens often enough that this should be something taught more often in more classes, but oh well. Okay. Is everybody okay out there? You guys doing all right? I keep asking that because, all right, I'm going to take that as a yes. Okay. So that was a good question. It was a perfect question, almost like I planted you about is the bottom always going to be empty? No, I could have a situation where it's dollars per pound or whatever, milligrams per liter, if I'm talking about medication, something. Okay.
Jeff, I think it was really informative too to know that it wasn't going to always be on the top. It's just
Yeah.
where it needs to cross cancel from.
Exactly. Okay. So let's take a look at the actual homework real quick, just to get an idea of what it looks like you're going to have to do yourself. I'm going to erase all this. Is that all right? Everybody got that? Okay, here he goes. So let's see what the homework looks like. Here we go. Yeah, so see how they refer back to that page 192. So you're going to want that page for sure. That's the one with all the chart of all the conversions. And then they just go for it. Miles to kilometers and so forth. So let me talk about metric system, and then that'll be it for today. I think that's a pretty good amount of stuff. So I'm gonna stop sharing this. I'm gonna go back up on my board. Metric system kicks so much ass. What you obviously know kilograms and kilometers, right? Does somebody know what kilo means?
1,000.
Yeah. So kilometer, 1 kilometer would be 1,000 meters. Now, very often people don't know this one. That would be 100 meters. Oh, Jeff, you need more room, dude. Got to write smaller. Hold up. I should have gotten the bigger. Oh, well, too bad. We know kilometers is 1,000 meters. There's something here that's 100 meters. There's something here that's 10 meters. And then, of course, meter is a meter. That's crazy. Somebody with me, what's happening up here? And then there's something here that means 1/10 of a meter. And these two, you know. What means 100th of a meter? What does it take 100 of to make a meter?
Centimeter.
Yeah. Which makes sense because, you know, cent is from the Roman centum. That means 100. And that's why we call a penny a cent, because it takes 100 of them to make a dollar. Anyway, it's not fair. And of course, what's the other one at 1,000th?
Millimeter.
Millimeter. So the important thing here is the prefix, kilo, and then of course no prefix, and then centi, and then milli.
Why'd you
Because
skip the decameter?
Sorry, go ahead.
Why'd you skip the decameter?
Because most people don't know it. So I was going to ask. So Vu, where's decameter go?
Over the 1/10 of a meter.
No.
1/10.
Deca is this one.
Oh, yeah.
This one, now real quick, what is, see this number? How it's after the whole number? Wouldn't we call that the first what place?
Tenth.
Yes, so this is deci. This would be decimeter. This is deca, which looks like this, which kind of sucks that these both have a D. They made this one dam. So I remember dam is big. So dam is the bigger one, right? Little decimeter, and then damn, is it decameter? Holy shit. Okay. And then who knows what goes here?
Hectometer.
Yeah. I like it. And this is related to something called a hectare. Has anyone ever heard of a hectare? It's like related to an acre of land.
Yeah.
Okay.
Yeah, hectare acre.
Yeah, hectometer. I love it. So we're also well aware. Here's something that's really cool about. So the first thing cool about metric, it's based on 10, which matches our number system. The second thing cool about metric, holy shit, that was my 15th puberty, is I can use it for length, I can use it for mass, kilogram, hectogram, so forth, and I can use it for volume, kiloliter, hectoliter, so forth. That's so much better than freaking feet and inches that have nothing to do with gallons and quarts, that have nothing to do with anything. It's like, holy shit, we're just all over the place.
Isn't there a saying or something
Yes,
about
good.
drinking chocolate milk or something?
Yes. Yes. You ready? What's really funny about this saying is, do you guys know what our silly unit of measurements are based on? Do you guys know the feet and the inches?
I think it was the king's body.
The king's body proportions, exactly. King of England. Didn't we have a revolution? But for some reason, we kept the freaking units. Foot was how big the dude's foot was. What the shit? Why was it like that? Because kings were from God, so their proportions were amazing. So we used those. And now we're the only country that still uses those damn things. Anyway, so what's really funny to me, though, is to know this system. You use King Henry. King Henry died Monday, drinking chocolate. I don't have any room here. Milk. Do you see how it relates to the prefixes? King Henry died Monday drinking chocolate milk. Now for grams, I hear sometimes giggling. King Henry died giggling, drinking chocolate milk. And for liters, I don't know, laughing. I don't know why he'd laugh as he dies. I don't know. All right, let me let that sink in. Now, I want to show you why you want to devote some of your memory cells in your brain to remembering this. I'm going to erase this down here. This is almost too nice to believe. And this, I don't think the book doesn't show you this, I don't think, which is unfortunate. Watch how beautiful this is. If I have 3 hectometers, and I want to know how many centimeters that is, every step is a step of 10. Does that make sense? Every step I take is a step of 10, because everything's separated by a factor of 10. So how many steps do I take from hectometer to centimeter?
2, 3,
4.
4. So how many, and watch this. Which direction did I go? That way. So I'm going to move the decimal 4 places that way. 3 hectometers is 1, 2, 3, 1, 2, 3, 4, 30,000 centimeters. Because every hectometer is 10 of these. Every one of these is 10 of these. Every one of these is 10 of these. So of course I do 10, 100,000, 10,000 times 3, 30,000. So let's try this. What if I had 18,000 deciliters? How many kiloliters would that be?
1, 2, 3, 4.
So then I move the decimal. Exactly.
Backwards.
1, 2, 3, 4. It'd be 1.8.
1.8.
Isn't that a lot easier than converting from teaspoons to gallons? Holy shit. This is only hard to us because we didn't grow up with it. So if I said in the air, make how big a decimeter is, you'd have no idea, but somebody in Europe would immediately do it. If I said do a foot, you kind of know what a foot is. If I said do a decimeter, I don't flipping know, because we didn't grow up with it. Okay, maybe some of you guys did. Maybe some of you guys started in another country, came to America, and then said, what is wrong with you people? I understand. Okay. Let's do another one. What about, what if I have 0.009 hectograms, and I want to know how many milligrams that is? Well, that's kind of mean, Jeff. Oh, it's,
1,
I am.
2, 1, 2, 3, 4, 5.
Yeah, so this is not that.
5.
So how do you do that down here? So yeah,
You
1,
go
2.
to the right, add a couple zeros, I guess.
Exactly. 1, 2, 3,
4, 5 is 900.
There you go. I don't need a grid, right? All I need is this. So if on a quiz or something, you knew King Henry died Monday, blah, 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 you could just write this list down, and then any problem I
Right.
give you just count. Isn't that beautiful?
That's great.
Okay.
You can remember.
I got one person. Let's.
We don't like simple in America.
I know. It's not the American way. I understand.
It's exactly how we're handling the pandemic.
Yeah. Let's not go there. Let me see. All right. Yeah.
Don't
So
you? Hey,
whole
Jeff.
section-
Oh, never mind.
Wait, sorry.
It's off topic. You know, the other gentleman mentioned the epidemic, and he brought it up. So I'm saying, don't you think they always have a solution before they create the problem? They create the problem, like, don't you feel like the America, well, not United States, like at some point has to reset the economy so they have something in plan, like it
This is
doesn't
gonna get a little too deep.
just-
Yeah. You don't want me ranting and raving about my personal opinion. That's not what this is supposed to be. I do have a personal opinion, and I'm not going to rant and rave about it.
Well, questions like that, like, well, never mind. I think.
Yeah, I'm sorry, dude. You understand this class is not that, right?
Yeah.
So,
It's
okay.
math. It's math class. Yeah.
So in office hours or something, I'd be happy to talk about that shit all day. I want to see if there's anything kind of freaky in this homework or not. I don't think so. I just want to show you this example. This is about how quickly glaciers move, the few that we have left. Let's not get into climate change either. Good Lord. Let's see. At one point, the San Rafael Glacier in Chile was moving 203 millimeters per day. And then they want you to take that to inches per hour. That's exactly like the Euros problem we just did, right? It's 203. So I'm just going to give you the first tiny little baby step of this problem. So they give me 203 millimeters per day. So they give me this, right? So I can go from millimeters to inches, and I can go from days to hours. And that, of course, you should know. So that's going to be exactly like the Euros problem, right? Because it's not an empty bottom. I like it. Ooh. Okay. And I think that's all I really got to say about the homework. Yeah, here's the one about medication, which is kind of like the one that most people run into. Yeah, okay. And then just I don't want to look ahead too much here, but if you look at the prep skills, we're going back to plotting points. And doing some visualizations. Remember good old pie charts and stuff? Because what we're about to get into this is going to be, yeah. So we're about to get into estimation and stuff. All right. So don't worry. We'll do that eventually.
Hey, Jeff.
Yes.
What's the time frame on the question that we're going to, what's the time limit that we're going to have on the quiz?
I'm not sure yet.
Okay.
I haven't finished making it yet, but it should come out at least an hour.
At least an hour.
Depends on how long it ends up being.
All right.
And here's something kind of nifty. Do you remember how the last quiz? Let me show it to you. The last quiz, I had to write in text the problems, right? Let me show you what I mean.
What's a good I guess the more questions, like, never mind.
Yeah, that's a good question. That's if I had a
What's a-
one-question quiz, that would be remarkably scary.
No,
So
what's
remember
a
this
good
quiz?
limit per? Well, we already expressed those details, but you said what's a good thing to aim for on a question, just to be I mean, for
Oh,
future references.
Listen. If you had 10 questions and you had 80 minutes, how many minutes per question should you average?
Well, you want to average less, and
No,
you want to.
listen. If you have 10 questions and you have a total of 80 minutes, how many minutes per question should you average?
15.
How many minutes? You got 80 minutes and 10 questions. So what's the minutes per question?
About a minute and a half.
Say
What was-
what?
About a minute and a half per question.
No,
8
no.
minutes.
What's happening
8
out there?
minutes.
Yeah, 8
8
minutes. So
minutes.
80 total minutes divided by 10 questions is 8 minutes per question. Does that make sense? So that's
Yes.
one of the first things I do when I get a
8
test.
minutes.
8 minutes.
You got it.
So that's one of the first things I do when I get a test or a quiz is I count how many problems there are. So I kind of keep track of myself as I move along. I try to get the ones done that are going to be quick. I say, that's going to be quick. Let me do that. That's going to be quick. Let me do that. And then I can see how many questions do I have left and how much time do I have left.
Yeah.
So I can figure out how much average I should spend on each one. Is that what you're talking about, Sal?
Yeah.
Okay.
Yeah.
Okay. So the quiz, thank God, I'm not going to have to type it in like this. I've discovered a way. Let me show you my other class. I feel like I should have known this earlier, but oh well, too bad. So your quiz is going to look more like this, where you actually you can download a copy of the quiz, and it's going to be more, more like it used to be with actual file. You with me? And of course, you can zoom in on that. You can blow it up, zoom in, or you can print it out and work right on it. You guys with me? I like that a lot better than the trying to type the text in, and then it gets really weird with tables and stuff, right? So now I can just do it in Word. That's a lot better. So I will send an email out reminding everybody that the quiz, I'm going to probably activate the quiz tomorrow morning at 8, and then I'm going to make it due the next day around noon or so. So due on Friday around noon. So if that doesn't work with anybody's working times, just let me know. And I can work with you individually on finding a good time to take it. You guys with me? Okay. All right. So tomorrow is no class, but I will have office hours, the extra office hours. And I'll send an email out when the quiz is active so you can get in there. Cool?
All right.
Okay. All right, guys.
All right. See you, I guess. You have office hours today, though.
No, tomorrow.
Tomorrow. All right. Sweet. All right.
All right.
Later.
Take it easy.
All right,
Go do something for yourself. Go walk around. Do something.
Yeah. All right. So you have a good day.
You take care, Sal.
All right. Bye.
Anybody
Are
need to
you
hang
done, Jeff?
Yeah.
I didn't hear you say you was done, so I don't know.
I pretty much intimated it. So what's up?
Okay. Ain't nothing to it. Thanks. Have a good day.
All right.
Hey Jeff, I was just wondering on 2-3, there's 2 separate assignments as of now. I was
Oh,
wondering
really? Let me see.
if
I might
that
have.
was an accident.
Oh, that's going to suck. Let me see. Did I do that? I did. Shit. Wait a minute. 2, 3. They both have similar due dates. That's interesting. Let me see if anybody's turned something in here. Yeah, shit. Did somebody turn in something in the other one? Oh, that sucks, Jeff. Yeah, of course. Damn. So I got to leave them both there. Damn it.
So just pick one of them. Just turn them in on one.
Yeah, just pick one. Yeah, you're right. Damn it.
All right, thank you.
Wait a minute. How did you see the other section 2-3?
I just look on my to-do tab and it says
Oh, that other one's not even in the module? You know what I mean? But I didn't remember it would show up in the to-do tab anyway. I think I was, anyway. Yeah, I didn't activate one of them, I thought, but apparently I did. So, oh well. Yeah, just pick one and do it there.
Okay, thank you.
Take care. How's everybody else? You guys all right?
What was he asking, that where to turn it in, or?
Oh, apparently, if you just go by the modules, you're fine, because there's only one section 2 through that shows up. There is another.
Okay.
I unfortunately had another. I think I created section 2, 3, and then I realized I already did, but I didn't delete the one that I made, so they're both there. So if you look at your to-do list, it shows up twice.
Oh, okay.
I didn't realize anyway, so that kind of sucks for me because somebody's already turned stuff into both of them, so I can't kill one of them. So
Oh.
yeah.
Okay. We'll see you tomorrow.
All right. And everybody else, you guys out there? I'm gonna leave. Oh.
Yeah, sorry I was late.
Oh yeah, that's fine. Do you have any questions? Alicia, are you out there? Alicia? All right, I'm gonna head out.
See you Monday.
All right, man.